Hi everybody, my name is Shiva Puladwan. I am an assistant professor in the School of Sustainable Engineering and the Built Environment at Arizona State University, and today I want to present our paper which is about simulating social pressure, evaluating risk behaviors in construction using augmented virtuality. So, construction industry is an inherently social environment, which means that workers need to work together in order to complete the construction task. So, teamwork is important in construction. But when we are talking about teamwork, we need to pay attention to some psychological concepts such as peer effect. So peer effect is building upon two psychological theories. The first one is social learning theory, which states that workers imitate and learn the same behaviors like their peers. And the other one is social information processing, which means that workers guide their behaviors by observing social cues. So based on these theories, workers tend to observe and learn required skills from their coworkers. We know that immersive environments have been widely used in the construction industry, but they have been mostly used for safety training and mostly at the individual level. So there is this gap in the knowledge to use these technologies in order to investigate risk-taking mechanisms at team level. So to address this gap, we need to pay attention to two factors. If we are going to use immersive technologies to investigate risk-taking behaviors, we need to consider place and plausibility illusion, which refers to the sense of presence. And it is important to simulate environments that we can give the sense to the individuals that they are actually in the real environment. And then we have social presence. Social presence is about the sense of being together. So, and it's most related to being able to communicate with others. So here you can see our hypothesis for this study. First, we want to see whether an integrated AV or augmented virtuality model with passive haptics can increase individual sense of presence. Then we want to see whether simulating virtual peers in the environment can increase individual sense of social presence. And then we want to see whether with increases in both sense of presence and social presence, individuals are more likely to change their risk-taking behaviors. And then lastly, we want to see whether participants with higher social and sense of presence show increases in their empathy level when witnessing peers experiencing incidents. In order to actually address this hypothesis, we have simulated a roofing task in an augmented virtuality environment, which included four components: a virtual environment, which is a US suburban area, passive haptics, for which we have used the physical section of a roof, a virtual worker that we have simulated environment to create a peer pressure, and environmental modalities, which included the environmental noises and also wind. So we have selected the roofing task because it is one of the hazardous tasks in the construction sector, and also it mostly needs to be performed within groups. So we have asked 64 individuals in order to perform the asphalt shingle installation on a physical section of a roof next to a safe and unsafe pier that I will explain in more details later. And when they were performing the task, we have captured their objective measures, like for example a stress level and emotional responses, and also we have used questionnaires in order to capture the subjective measures, like for example sense of presence, social presence, and risk perception. Here you can see the development process of this augmented virtuality environment. So the augmented virtuality environment is a combination of both virtual and also actual world. In order to create the virtual peer, we have asked an individual to wear the motion capture suit and then perform different kind of roofing scenarios, like for example going up and down the roof. And then using the object track systems, all these movements were captured in order to create a virtual peer, and then we imported all those animations into Unity 3D in order to create that virtual environment. as you can see here. Also, we have considered awareness cues in this virtual environment, like visual cues. For example, the virtual peer was exactly similar to a real worker. For example, he was going up and down the roof very naturally. He was actually posing in a very natural way. And we have also simulated auditory cues. For example, when he was using the phone as an unsafe behavior, he was um, having a kind of work-related and life-related natural conversations. And also when he was going up and down the roof, he was making some noises like ouch when he was sleeping on the roof. And we have considered three experimental conditions. In condition A, subjects were exposed to the unsafe peer who was behaving unsafe. So he was sucking on the phone, he was leaning on the guardrail, and at the end he experienced the fall. In the second condition, which was condition B, subjects needed to perform the task next to unsafe peer, and also they needed to compete with him. And they needed to install the shingles faster than him to receive extra compensation. And then in condition C, they were exposed to a safe peer who was performing the task very cautiously. So we have assigned half of the subjects into condition A and condition B, and the other half were assigned to condition C. So by this experimental design, we were able to do both within and between subjects analysis. In this slide, you can see a general overview of the experimental design. So you can see the actual subject in the environment who is here. He is installing the shingles on the physical section of the roof. So this is his view. You can see that he can see the roof, he can see his body, he can see the shingles, but the rest of the environment is virtual. It is a projection of a US suburban area, and you see that he is seeing the virtual worker next to him. And then when he was performing the task in this environment, we also equipped him with different kind of wearable sensing technologies, as you see here, in order to capture the real-time physiological and neurophysiological responses. And now let's look at the findings. So we have used a well-established questionnaires in order to measure participants' sense of presence by asking questions like, to what extent you feel present in the environment. And based on the results, we realized that the developed AV model could highly increase their sense of presence. And then we also used well-established questionnaires in order to measure their social presence by asking questions like, how much did the visual and auditory aspects of the environment involve you? And as you can see in this graph, the gray color is showing their auditory perception, and the orange color is showing their visual perception. So we see that most of them reported a value higher than the average, which shows that the developed environment could highly increase their social presence. We also measured their risk-taking behavior with subjective measures first. So for that, we have actually showed them the recorded videos from those three conditions, and we asked them to report their frequency and severity of the unsafe behaviors based on their perception, and then by multiplying these two factors, we could calculate their individual risk perception. So as you see in this graph, participants had higher risk perception in condition B, where they were exposed to the unsafe peer that they also needed to compete with him. And then for further investigation, we have divided the participants into two groups based on their average sense of presence. So those that have a score higher than the average were in the high sense of presence group, and those that they had a score less than the average, they were in the low sense of presence group. And then we have compared their subjective risk perception together. So here the yellow color is showing the risk perception for the high sense of presence group, and you can see that overall three experimental conditions, they had higher perceptions of risk. And you can see that the highest value was related to condition B, where they needed to work with unsafe peer and also compete with him. And we also measured their risk-taking behavior based on objective measures. For example, we use their electrodermal activity, which is the immediate response to the hazard in the environment. And you see again the yellow color, which is related to the high sense of presence group, is higher in all the three conditions. And we can see the highest value in condition B. We also measured their acceleration magnitude or movement intensity over condition A and B, where they were exposed to unsafe peer. And here you can see that they had higher acceleration magnitude in condition B. So we also measure participants' social presence, the relationship between social presence and empathy. So empathy is the ability to understand and share feelings with others. So here you can see the average EDR value for 32 participants. Before and after the moment of peer's fall, because the peer experienced a fall in the environment. And based on this graph, we can see that participants' average emotional responses reach to the highest value when they observe the peers fall with the moments before that, compared with the moments before that. So based on our results, we can conclude that the developed environment could highly increase participants' sense of presence and also social presence. And those that they had higher sense of presence, they could further perceive the potential risks and they were less engaged in risk-taking behaviors. And also we realized that the developed environment could highly trigger the sense of empathy. Thank you so much for your attention. If you have any questions, please contact me with this email address. Thank you.